All right, so let's give a short round of applause to welcome Doug and Nico and let them take it away.
Awesome, thanks so much. And just a quick sanity check, people can hear in the back, it's okay? Not too loud, not too quiet?
Testing, 1, 2, 3.
All works? Okay, fantastic. All right, thank you so much. A bit of background on us. So as Ava mentioned, my name is Nico. I'm on the founding team of Comet. Started as a research scientist at Yale maybe 5-6 years ago. Got into ML working on weather forecasting models. Started a company and then started building Comet. And then maybe, Doug, do you want to say a quick intro?
Sure. I guess if you're watching us on video, go watch the previous talk from Dr. Doug Eck that was talking about generative media. It's funny, so my name is Dr. Doug Blank, and Doug and I were both at, as he mentioned, in grad school together at Indiana University, Bloomington, in the 90s. And there weren't that many of us that were like committed to doing neural networks. And Doug was one, and I was another. And Doug was focused on sequential problem, and I was focused on making analogies. And so it's funny to see where we are now. I didn't know that Doug was going to be talking earlier. So it's very funny to see how our lives have been very similar. And we'll talk a little bit about that as we go. So, I'll hand this over to Nico. We'll talk about some case studies from the perspective of our company, Comet.com. And then I'll talk a little bit about large language models, both fails and how you might deal with those in production at a company.
Awesome. Thanks, Doug. So just to give a bit of background about Comet, I think some of you may have been exposed to us this week in the notebooks associated with this intro course. We build MLOps software to hopefully make your lives a bit easier building models. All of the founding team, Doug, myself, and the other co-founders all came to this basically building for the pain points that we wanted to have solved. The other two co-founders, Gideon, who was at Google at the time, built for you. So I'm hoping that over the course of this week, as you maybe trained your first neural networks, that was a bit easier. And we support some of the best research teams in the world and best universities in the world as well. Mila, which Doug Eck mentioned, MIT, and many, many more. And what we want to focus on today, Doug and I, my Doug, not Doug Eck, we're talking about as we prepared this talk is you've just spent a week diving really deep into machine learning, into artificial intelligence. You've learned the basics. You understand how these systems work. You understand how to build them, how to code them. We're not going to give you any more information on those topics than you already received. What we spend all of our time doing and what we think might be interesting for all of you now is we spend our time working with businesses, companies, enterprises who are trying to take these models and do something useful with them, right? Make money, save money, make things more efficient in the real world. And as beautiful and elegant as all of this math and code looks, in the real world, things can get a little messy for reasons that you might not expect. So we're going to do a couple case studies, some interesting case studies from some of our customers, models they've built. In most cases, frankly, very, very simple models, where nevertheless things pop up that you wouldn't expect. I'm going to see if this first week of learning about deep learning will provide any of you ideas as to how to diagnose these issues. And then, as Doug mentioned, we'll talk about large language models, again, with a specific focus on some of the interesting things that emerge around large language models when you try to take them into production and do things with them. So that's our plan. Just a quick primer. These are very, very simple. This is like palm to forehead material for anyone who's built these things. But as we go through these case studies, think about if it might be a data problem, a model problem, or maybe a system problem, right? And we'll go from there. Awesome. Okay. So our first example is a customer of ours who we can't name, but you can probably pick one of the 2 or 3 companies you expect this to be. It's one of them. A team's building a user verification model, right? So basic problem, given a photo uploaded by any user, detect whether the photo matches the actual user's profile picture. The marketed purpose of this model is to minimize fraudulent accounts. Between you and me, there's a couple other types of photos that commonly appear on dating apps that this was also being used to detect and minimize, but we won't talk about those. And so think about this from a system perspective. It's actually quite simple, right? What's our data set here? Images from the app, right? And these are manually labeled, so they have a huge team of manual labelers, going through and labeling true photos from user accounts and false photos from known fraudulent accounts. Very, very simple, neural classifier. Sends it into production. You have an app, you have a model now, running inference in real time in the application, minimizing fraudulent accounts. And they deployed this model, and all goes well. Fraudulent accounts, are like by a large margin going down. Everyone's happy. The business is happy. They're spending way less money on manual tasks for identifying these things. Happy, happy, happy. Until all of a sudden it stops working, right? Like after a couple of months, we start to see this deterioration in model performance, down 10%, down 15%. And to give you a little bit of a sense of like the economic impact of this degradation in model performance, like a 10% decrease in model accuracy is an additional 10,000 manual moderations per day. So from their support team, it was like in the hundreds of thousands of dollars a month. So it's an expensive problem. Anyone have a first guess as to what you would do first if you're working on this team of engineers, your model starts to get worse and worse? You can just shout it out, and I'll repeat. No ideas. Okay. We'll speed through the first attempt. It was just a retraining, right? You know, say no. The answer is out there. You just have to yell it. So the first idea is, look, we probably just have some data drift, right? There was some corpus of data which we used to train this model offline. We achieved like a high enough performance to deploy this model, and now the data that our model is seeing out there in the wild is different, right? It's seeing new data. Let's gather the new data, and let's build a new data set, and we'll retrain our model. And it should work, right? Little to no impact. Makes no impact on the performance of this model. They're completely stuck. So retraining doesn't work. Think about the full system that's going into this model in production. Any ideas at all as to what might be happening here?
People gaming the model better.
It's a good idea, and it might have been happening. Anything else? Any other possibilities? So what they found out, and this was a bit of a palm to forehead moment for them, it was just a new iPhone. And the new iPhone camera was taking photos with a significantly higher resolution than the ones that the initial model had been trained on, that the existing model didn't have enough layers to actually capture that information, so it was doing horribly. So the solution here was literally to add like 2 layers to the same architecture and retrain, and everything worked. Very, very funny story. I think the only lesson here for people, by the way, just as a show of hands, like who here is interested in going to work in ML and industry after MIT as a data scientist, machine learning engineer? So there's no like silver bullet to this story. There's no sort of like algorithmic way to predict this. Just weird things are going to happen. Think about the full system, end to end, from even potentially the machine, assembling the data that you're maybe using to build your model upon. Okay, second case study. Leading e-commerce company. And our task here is listing and ad recommendations. So this is a very similar use case to one you might experience every day on Netflix or Max.com, right? You log in, you have a curated set of columns and rows of titles. In that context, their goal is to keep you in the app as long as possible, keep you happy watching movies, have that monthly 1099 continue to deposit into their bank account from yours. In this case, they're trying to get you to buy clothes, right? So how do you build a good system that's going to effectively retrieve and list sort of top candidate advertisements or just listings from the application in a way that fits a given user profile? So the specific problem as formulated by this one of our customers: for a given user, maximize the likelihood of a click, on a served advertisement or listing. And our goal is like maximizing revenue, right? So you can look at every single user session, and you can build sort of like a labeled data set based on ones that led to a sale. So in this case, our data set is embeddings of historic engagement data. So this is a little bit interesting, and there's like there are a handful of good papers on this if you want to learn more. But this data set is actually of much more than actual purchases. So other activities that a user might engage in during a session on a website that are directionally suggestive of leading to a buy. So search queries, item favorites, views, add to carts, and purchases are all sort of, labeled as true samples in this case. Build an embedding model that basically retrieves a top N, listing candidates, whether it's advertisements or actual, items based on a given user profile, right? So again, build this model, train this model. You have a service running in production. You have a shopper. And this model works great. There's actually no issue with the performance of this model in production. The peculiar thing here, and let me just say, I think I actually already touched on this a second ago, but just a bit more of a deep dive into the specific system here for retrieval and Rex ranking. We can come back if people have questions later. So there's actually no issue with the performance of this model. There's no degradation. There's no issue. It's just really hard to beat. Like the team wants to build a better model. They have a big team of researchers, great researchers. They're testing new architectures. Gathering a ton more data. It's not working. Like the production model is just better, and they can't make it. They can't build something better. It's very hard to sort of get. To put it a different way, they think they have breakthroughs. They think they see these offline performance metrics. So we have this new model. It's like 8% better. They ship it. Doesn't do any better. So there's sort of it's like a bifurcated issue here. You have amazing results offline leading to no effect online. And then also, even with lots more data and sophisticated models, the online model keeps outperforming any sort of new candidate. So any thoughts as to why it's so hard to beat the production model?
Is it just seasonal trends?
It's a really good idea.
I guess in training there are different local minima, so maybe it just happened to be like a really, really good one that was subsequently.
So I think a possible, local minima, it's a good idea. And the first idea, sorry, I'm supposed to repeat this because we're on video, was as a seasonal model. It's another good idea. Any other ideas as to what might be happening here? Yeah, in the back.
Consumer data, like consumer segmentation.
Consumer segmentation is a very good idea. Anything else? Yeah.
Distribution shifts of data over time, and then as you move on in time, then you have like distributions that are more accurate to that point in time.
Yeah, it's a very good idea as well. These are all completely plausible as well. Yes?
Are they just not deploying the models quickly enough? If someone searches for something, they might want it then, right now, not a week from now.
Yeah, another good idea. All of these are totally feasible explanations for what was happening to prevent this team from making a better model. What was in fact happening, and this is again a bit of a palm to forehead moment, there's a theme here. Whenever you go work for a big team of data scientists, oftentimes the solution is going to be a bit of a palm to forehead. But a researcher realized after a while that the way that they were generating the training data set to train a new model, the historical data that was being was retrieved using embeddings from the prod model itself. So basically, the data that you're using to build a better model is coming from embeddings that are being produced by the model in production. So the odds are pretty good that the prod model will do well compared to that data. So it was very, very hard to do. So it was basically like the new model was being trained like with a mask on its face a little bit, and it was not gonna do better. And I wanna make sure that I speed up here a little bit to leave the other Doug time to talk about his stuff. So the interesting system solution that they devised here to prevent this was they actually built multiple retrieval agents in production, and so this is also sometimes talked about as like shadow models, where you might deploy like 4 or 5 models in a production environment at once, but only actually allow one of those models to serve predictions to an end user. That's a great way to also build like 4 or 5 different candidates at the same time using real-time data from your user base without necessarily overcomplicating a system and still having a fantastic user experience. So by having multiple retrieval engines in production, what it allowed them to do is they had multiple models that were each generating different sets of embeddings based on the user activity in the application, and they would take the embeddings from one of those retrieval engines to train a new model, and then just don't compare it to the model that made those embeddings, right? Ultimately, like, somewhat simple. So those are 2 case studies that Doug and I find very, very funny, and oftentimes, again, there's no silver lining or silver bullet here for you all, but you should completely go work in industry and just be prepared for, some non-standard or non-expected things to start happening once you do. I'm going to let Doug hop up here and talk about LLMs next.
All right. Thank you, Nico.
Yeah, of course.
So Comet's been a company helping other companies do machine learning for about 5 or 6 years now. And so those 2 case studies are ones that we actually know about. We have a lot of customers that don't actually give us insight into how they have something that doesn't work. So those are 2 that we were able to discover. What I want to talk about now is a different kind of animal, and although this is probably, we have more customers asking us about large language models than we have them ask about anything. So we don't have those kind of case studies from existing customers right now. However, we can probably guess what some of these issues are that they're having. And so what I want to do is, first of all, ask, how many of you, be honest now, have used ChatGPT or some other model? Raise your hand. Okay. I see a few people that didn't raise their hand. I'm not going to point you out, but almost everybody has used one of these models. So have you used it for anything useful and important? And this is not an implication of guilt. I know this is, being students where you have perhaps something due. All right, so people are actually getting use of these, and that's great. And for those of you who have tried it, have you seen anything funny or weird or wrong? All right, so okay, almost as many people that have used ChatGPT have seen something wrong or funny, not unusual. So what I want to do is think about how we could actually work with large language models in production. But in order to do that, and also for you just to think about those LLMs yourself, I want to take a quick look at how they work. And this is really 30,000 feet bird's eye view. So as you may know that systems like ChatGPT are based on transformers, and they're not exactly the same. There's been a lot of tweaks with transformers over the years. And it's also true that we don't know exactly what goes into some of the later models. They started out being pretty open and having papers that described all of the gory details. Not so much anymore. Why might that be? Money? Yeah. So indeed, this is big business. So if you have a system that's able to, beat the competing ChatGPT model or chatbot, then you're ahead of the game. So the GPTs are often just decoder-only systems, but looking at this transformer model, I think the one thing that I wanted to talk about is that and stress is the inputs are largely a block of things that get encoded all at once, and then these decoders, as we saw in the last talk, you have things that get generated, and you've seen this too in the web page. If you've used ChatGPT, you get a little bit of text and then it generates more and it generates more. So it's iterative, it builds. And just a little bit of this is an old transformer problem of translation, but you can imagine this in the same kind of system used for ChatGPT. So you have the inputs that come in all as one block, and every token gets converted into a set of numbers, either through an embedding system, and maybe those were learned previously, or maybe they're being learned as the entire model is being trained. And it outputs something. And then that output comes back in as an input to the decoder. So you've got that one big block of input, plus now you have the output of whatever you just outputted. And so this, the previous output from your own model comes back in as input. And so then you end up with a complete translation, or in ChatGPT, you get an entire paragraph of output. Now, this has been called by some stochastic parrots, and it is very statistical. So the words, the tokens that are being output are based on the statistics, and you can ramp up that variability, the noise in the system, so you get more creativity, or you can make it more deterministic. And also, starting with ChatGPT 3, people realize that you can add a little bit more of a context before the actual prompt. So, and you've probably seen these kinds of things that you can add to a prompt, like think about this problem step by step, or you are a useful assistant. And it turns out, who would have ever guessed this? I wouldn't have. That adding things like that can really affect the kinds of output and the quality of the output that these systems give. And this is amazing, and it's it really, I think it has big implications about how these systems work. Of course, this is called prompt engineering now, and you can probably get a job being a prompt engineer, making very good money. So what I want to do now is, now that you have a glimpse of how those systems work, we can take a look at some actual fails, and we can think about them, reason about them, why they fail, why don't they work. So the first of these is, the input is given a coded sentence, and then the system is supposed to output what the uncoded system is. And you may have, if you've played with simple codes, there's this rot13, rotation 13. So you just take the character and you rotate it 13 more. And so they tried this task, give it the input, the coded input, tell it it's rot13 or rot2, and let the system see if it can come up with the decoded answer. So what do you think? Is this something that ChatGPT can do? Or not? Yeah.
No, because the tokens aren't letter by letter. They can be like groups of letters, so it's not necessarily recognizing it as like A, B, C.
Okay, so this, if I can paraphrase you, it's not a task that they typically see. It's not a given, it's not the kind of sequences that they were trained on. But wait a minute, they actually are trained on that. You'll see if you train on the entire internet, you'll probably find examples in Wikipedia of rote 13 and probably rote 2. And in fact, the people that did this study, they looked at that in the corpus, how often rote 13 and rote 2 examples, and it turns out that rote 13 was 60 times more common. So there actually are examples, but will that varying disparity in probabilities play a role in how it does? Yeah, absolutely. So if you take a look at what the actual output is, and it's sort of amazing, crazy that you can take a system that wasn't trained to do decoding, and you can ask it to decode something, and it does a pretty good job. Makes mistakes, though, and it makes mistakes on those where it doesn't see as many examples. Okay, so that's a minor fail. Here's one that is, this one makes me a little sad, I must admit. So here's an example, and the problem is, so they start out with a very nice prompt. You're a critical and unbiased writing professor. You know, you're going to set the stage for this ChatGPT to be in the right mode when it grades this essay. Output the following format. Essay score out of 10, and then here's the essay. And it's followed by an essay. This is an example from Chip Nguyen. And so is this going to work or is this not going to work? So this is a tricky question. It's going to work in that you're going to get output, but what does it mean? So let's take a look at these, and we don't have to read exactly what they are, but the first thing is, you know, the one on the left, essay score 7 out of 10. This essay has some merit. Okay, that's good. If you're getting feedback per your professor and they start out with that, you're on the right track. Okay, let's look at the other one. Essay score 4 out of 10. Okay, not so good. All right, while the essay captures, this is not a good start if you're getting feedback. While the essay captures, you know, some, it lacks depth and analysis. Okay, so thinking about the output and knowing a little bit about how these systems work, why might I be sad about this? Yeah.
Was it the exact same input for both?
Yes, it was. So the question is, was it the same exact input for both of these? And yes. So let's see if I can get some. Yes.
Is it because like all the data for like essay was taken on academic writing instead of like creative writing, or like this kind of stereotype of what a good essay should be like?
Yeah. So the question is, was this trained to do this? And I think the answer is no. This is just regular ChatGPT working. So let me give you a hint. What's the output? How does the output come out of ChatGPT? Iteratively, right? And so what's the first thing that these two things have to do? They have to give you a score. This one is a 4 out of 10. So the rest of the text that gets generated has to be driven by that. And so it's going to, whatever, I didn't really read these to see, I doubt that there's really anything useful in this feedback, but the rest of the text is going to make sure it matches that score. So if you got a 4 out of 10, then the text is going to validate that 4 out of 10. That makes me a little bit sad to know that that's the way these systems are working. It's consistent. It's giving you what you want. So it sort of works because it looks sort of like that essay was graded. Would you say that that essay was graded? I see some skeptical no's. Would you want your essay graded this way? No. Okay. All right, here's another one. And the question is, who is Evelyn Hartwell? Can you answer this question? So a good answer might be, I don't know. Evelyn Hartwell does not exist. That's a made-up name. So what do you think will happen if you ask this question to a chat bot? It's going to give you an answer. It's going to give you a great answer. Here are 4 different samples. Evelyn Hartwell is an American author. I'm sure it's seen that phrase before. Evelyn Hartwell is a Canadian ballerina. That sounds very realistic. Evelyn Hartwell is an American actress known for her roles in the television series Girlfriends and The Parkers. I don't even know if those exist. Evelyn Hartwell is an American television producer and philanthropist. She's a nice person. Okay, so, you know, you may have seen these before, and actually, if you read the source down below, you see that these are called hallucinations. And I must admit that I hate that term because it implies that sometimes ChatGPT is hallucinating. You know, maybe it got some bad input and, you know, it started hallucinating. But no, that's not true. It's just outputting the output the way that it normally does. So I thought, what is hallucination? What is the agreed upon definition? So I didn't want to cite somebody, so I asked ChatGPT so I can just put that text up there, and this is pretty good. When we say that an AI model hallucinates, we're referring to situations where the model generates outputs that seem unrealistic, nonsensical, or diverge significantly. But who knows that? ChatGPT doesn't know that. You have to, use your own knowledge, or maybe you have to go searching for Evelyn Hartwell to realize that she doesn't actually exist. And you can only do that through your own investigation. So how could you possibly put this into production when you're getting output that is all over the map? So, you could ask the question, what's different about the model when it's hallucinating versus when it's not? There's actually some idea that you might come up with. What might be a possibility that's happening inside the model doesn't know that from the outside, but if you looked inside, what might be happening? Any ideas? There's probably some. If you look at the output, it's very low probability. Evelyn Hartwell is low probability. We'll pick one, and then it's Anne. Okay, if you say Anne, you better go with the next word that starts with a vowel. Okay, Anne American. Okay, an American what? Low probabilities. Let's pick one. Ballerina. So if you looked at the internal system, you might find that there are some ways to measure that internally. And then what should it do? There's actually some work showing that you can actually use the model itself to give you a pretty good estimation of how well of an answer it is. And that's pretty fascinating. There are some measurements you can do, but they're very expensive, very time-consuming to compute. But I'll show you the code that's actually doing this. Who is Evelyn Hartwell? I'm sorry, I don't have that specific information. Who's Nicolas Cage? Nicolas Cage is an American actor. Okay, that one is good. So the code that actually does that is it's using the chatbot itself, and I've got a link to this code. This is some Python code. Basically, it's got a little bit of self-similarity score. It asks ChatGPT, what do you think about this? Comes back with something very quickly, within a half a second. And then it's hard-coded just to say if it's too low, sorry, I don't know. So I want to move to some epic fails now. You may have heard about the lawyer that submitted a ChatGPT written motion to the court. Did you hear about this? We'll make these slides available, or you can Google it and you'll probably find it. But this actually happened in New York, Manhattan, and the lawyer, overworked, I'm sure, one of his assistants created a 10-page brief citing more than half a dozen court decisions with names like Martinez versus Delta Airlines, Zickerman versus Korean Airlines. These cases don't exist. Completely fabricated, made up out of whole cloth, hallucinated. And the judge or the lawyer was just in court explaining what happened and showed some output from ChatGPT, and ChatGPT ended that with, "I hope that helps." It did not. I don't know if he got disbarred or not, but serious problem with that. Here's another, I wouldn't say it's an epic fail, but you can see where this person is going with the prompt. If one woman can make one baby in 9 months, oh, I recognize this pattern. This is math. How many months does it take 9 women to make one baby? And of course, ChatGPT doesn't know about babies and women and, how you make one. Probably, you could say it does in one way, but not in the way that it would be able to answer this question. Of course, ChatGPT did the math. And of course, if... No. 9 women cannot make 1 baby in 1 month. No, it doesn't work like that. So, epic fail on that. So, in summary, and this is a little bit opinionated, if I can go with the first speaker, the other Dr. Doug. LLM text generation is a bit of a parlor trick, I would say. So it's definitely doing something. It's learning patterns it's amazing. It's able to create this text, but we're using that in a way that's really simplified and a little bit stupid. We're using it to, flip a coin and generate a word, flip another coin, generate another word, and it's all consistent. Or if it's music, it can actually sound really good. But when it's text, that means something very, very different. I actually heard somebody describe ChatGPT this way. So I went to ChatGPT and I gave it a question and it went off and did some research and then it came back with, no, that is not what ChatGPT does. It does not do research. It doesn't do logic. It doesn't do encodings. It detects patterns and statistics. LLM results may be racist, unethical, demeaning, and just plain weird. LLMs don't understand much of anything. One of my colleagues thought that ChatGPT would be good at the New York Times Connections. Do you know this game? It's very fun. You get a bunch of words, and you have to pick the way that they're connected in 4 categories. ChatGPT is not good at that. It's not the kind of thing it was trained on to create. This is one that I've seen often. LLMs don't do well on non-textual inputs. And I mean non-text, you can put text, make them text, but a chess diagram, you say you lay out a chess, or even tic-tac-toe. You got some X's and O's, and you ask it, what's your next move, or who won? That's not a very good task for ChatGPT, because it's not a textual sequence problem. They don't deal very well with those. They can answer you, yeah, you'll win. No, that's not right. LLMs don't know what they don't know. There's no idea of truth or, punching down or inappropriate or, anything like that. Don't talk about Nazis. It just doesn't know that. LLMs do give you back output, but the kind of output that you expect, that you want. And what the output actually says is anybody's guess. So my opinion is that LLMs are amazing. They're stunning. Dr. Eck showed examples that he did back in 2002 of music generation. Same kind of problem. It wasn't that good of music, but it's amazing that these systems can do that. So what are they good for today? What do you use ChatGPT or others, Bing, for? Yeah. Coding? You write pretty good code? I've looked at code. I've never used it. I write a lot of code for my work. But sometimes let's see what ChatGPT would do just to get a hint. But I thought, oh, that's not bad. Oh, there's a bug there. What else? Yeah. Inspiration. Yes. I use ChatGPT a lot for just getting ideas. I created a blog on genealogy, and I needed a good name, and it didn't give me good names, but it inspired me then. So it was part of the creative process. I do know one group. I lived in San Francisco, and I went to a meetup there, and there was a group there that named their internal group based on a name that ChatGPT had given them. So definitely inspired. Yeah.
Helping you write Christmas cards, I should say.
Helping you write Christmas cards. Yeah. My wife is a professional in education, and she has to write a lot of cover letters and personal letters, and sometimes she does fundraising. she uses ChatGPT for, generating the structure, and then she'll go through and tweak it a little bit. So definitely. Yes, what else is useful?
Summarizing long acts which are passed by Congress, like the Inflation Reduction Act.
Oh. Summarizing large blocks of text. I would be a little bit worried about that. I'm not sure I would trust that 100%. Custom GPT. Okay, so that's a different kettle of fish, indeed. So there's definitely, and I see lots of ideas of ways that you can use ChatGPT usefully and successfully, and we can talk about that perhaps when the talk is over. But I guess I just wanted to end with that there are some good uses for ChatGPT, ones that are ethical and that are, you can trust and you can be inspired by. But not every task, is appropriate to give to ChatGPT. Grading assignments, I would argue, do not do that. If you know anybody that's like grading by giving it to ChatGPT, I want to talk to them, one-on-one, over coffee. But I don't think that's a good idea. We should talk about that more. So to wrap up everything that Nico and I talked about today, takeaways from this talk. Our suggestion would be use a modular framework, perhaps by a company, that gives you the ability to manage your experiments, keep track of them, log all of your metrics, your hyperparameters, keep track of your model storage, your deployment. Get a good hand on that. Model your production monitors. Have alerts. And be willing to be flexible with what happens. Look at the data. Look at the training. Dig down and maybe add additional parts to that pipeline. Nothing is static in this world. Dr. Doug Eck and Dr. Doug Blank have been doing this for 30 years, and I'm sure he would agree with me. We would never imagine that these systems are able to do what they do today. It's fast, it's interesting, it's exciting. There is a job for you, no doubt. But you have to stay on top of the processes and the practices and make sure that you use these in appropriate ethical ways. Nico, I think that's the end.
Thanks for the great talk. I have a quick question on the grading problem. So you mentioned that, okay, if the ChatGPT gives the grade first, then they need to use all the paragraph to solidify their grades. If you make the reverse, like ask it to give the grades at last, then will it just take what they use and then give the grade?
I would love to read that paper at NeurIPS next year. Or I hear you have some projects due tomorrow. Is that true? That would be a great experiment to try. Does it affect? If you force the output to be one way first versus another, does that have a large impact? I would think it does, but you never know with these models. You really have to test them out.
Hello, great talk. I just had a question. So could you use corrected user output to train models to prevent hallucinations? So if very low probabilities, if you could tell ChatGPT you were wrong, could that change the hallucination from happening again?
Yeah, there are definitely systems, custom models that do take ChatGPT and they fine-tune it to give you specific answers. One of the big problems, though, is that if you're trying to monitor this in production, there are too many to do manually. You have to come up with automatic measurements, so that these will pop out and you can go in and look at them. But once you do find them, you could definitely fine-tune models. That's a thing.
With the same prompt, why do you end up getting different outputs? Is the entropy of the system somehow disturbed from a previous run? does it change? Like, what causes that variance?
I can let you answer one of these. Okay. So these are built into a lot of the models. There's typically a value between like 0 and 1 or 0 and 10. And you can set that value to be 7, give you a lot of variability. You can make it 1, and it'll be more deterministic. I don't know exactly what that number does, for example, in ChatGPT. I suspect what it does is when the probabilities come on the output and it's deciding what token to output next, if you have a deterministic number, highly deterministic, it'll go with the highest probability, just max, and that'll be the output. And so you'll get the same output every time. You move that up and then it'll say, okay, I'll maybe go with a lower probability word to give you some more creativity and craziness. It's fun to play with. That's a setting you can, I believe, set on the dashboard of ChatGPT.
Hi. In the first set, we saw that some models didn't perform well when they were higher quality images. So how would you suggest working on with that problem? Because that problem you would least expect to happen during the production. So let's say for the problem that we saw in the first set for a dating app, that they recognized some images, but when the camera was changed, a higher quality camera was used, the models didn't perform well. Right. So how would you, for any scenario, when you're trying to work on your models, how would you go ahead trying to solve that problems? Because that's the area you least expect to be.
Yeah. It's a great, can you hear me, by the way? Is this on? Okay. So we spent a lot of time with this team when they were dealing with this. It's kind of like you have to monitor the entire system and be aware that at some cadence, maybe every year or two, something extraneous to the system will happen like this, like a new iPhone will launch, unless you have that coded in, like every 18 months, send myself an alert over email that we should probably add a layer to our architecture because there's probably iPhone 16 is out now, like something like that. It's hard to do deterministically. And the lesson that they took was they do like an annual like architecture review from like a philosophical perspective, and they do their best to think about all the possible like external perturbations to their system that was totally bulletproof a year ago, but now might not be, right? Yeah.
I have a question about the LLM business use cases right now. So I'm curious what you guys are seeing from the business point of view of the market for LLMs with all of these problems that you mentioned, right? I assume the marketplace for LLMs is very much evolving, right? And I'm curious what you're seeing from the customer's side of things, right? What is the market for LLMs today?
Yeah, I can take that. So without sharing specifics, I think some generalizable trends we're seeing, and you can probably all infer this from the talk that Doug just gave, but I would say as a general rule, teams are more wary of deploying LLM services into applications where the model might be making an important decision with a customer. So if it's going to impact like a buying motion, or if it's going to impact something like that, that's going to have a hit on the top line financial performance, it's less likely that you'll see a model shipped. Teams are very eager to ship LLM models for internal use cases. So coding, we see a lot of teams who are building internal agents to speed up the productivity of their devs. We see a lot of teams shipping models to do like note annotation from internal meetings or summarizing videos. So if someone misses a meeting, just like take the Zoom recording and email out the synopsis. So a lot of things that are aimed at improving the efficacy and the efficiency of internal teams. That's a very rough thing, but we're seeing that as like a general rule.
It's very similar to where we were like 5 or 6 years ago when people were doing just regular neural network experimentation. Back then, we would ask a team, how are you keeping track and logging your results? Well, I have an Excel spreadsheet, and I run this, and I copy, and I paste it. And there were so many teams doing that, and I think there's probably a lot of teams doing that with LLMs. So the first low-hanging fruit that we're working on is just making it easy to log and then be able to visualize, sort through, find. You take a model, it gives the output. You fine-tune the model, it gives slightly different output. Being able to track that lineage of the model, all of those kind of what we now call ML ops, which is an analogy with DevOps, a developmental system, software engineering kind of systems. But this is for machine learning.
Thank you for your talk. I can imagine how in production it would be very useful if your LLM could ask you a question. Me personally, I've been trying really hard to force ChatGPT to ask me a question.
Yep.
Is that due to it being trained on text? How would, is it possible to change it, the neural net such that it does ask questions?
I don't know anything about the details of, how ChatGPT works or, the internal algorithm. But as mentioned before, you can fine tune it to do anything that you want. So you can take a large language model and, if you want it to do something that's inappropriate, you could train it to do that. If you want to train it to ask you questions, you can do that. So it's really this fine tuning is what you can take a model and then use it to go one direction or another.
I found very interesting the hallucination part, like using the low probability to detect when it's making up something. I wonder if that works also for the opposite problem, when it spit out something textually from the training set. For example, New York Times is suing ChatGPT because some of the articles are very similar, if not the same. So how do you tackle that problem? Is the probability 100%, or is that something that needs something different?
Well, what would the measurement be?
How do you detect this using exactly the same from the training? So it's taking a text from the training set, outputting it completely it was.
That's a hard problem because the training set is the entire, internet. Mm-hmm. So,
my main one is outputting you ask a question and it will output exactly the same thing. So you want it to be a little mixed up or a little different.
Or you want to get different outputs.
Yeah, not textually exactly what I have seen before.
I think you could pump up the randomness on that number, and if you change that number, you start getting wilder and wilder deviations. You change it a little bit, you get some variability. You change it a lot, you get a lot of variability. Yeah, so that is built into these models.
Okay, maybe one more question. Okay, come over. Sorry, she raised first.
Enthusiastic hand up is the last question of the night.
Okay.
Hi, thanks for the presentation. I'm curious about your company. Could you share what's the differentiator of your company compared with your competitors?
Sure. Yeah, happy to talk about it. We were hoping not to make this a common sales pitch, so I think I'll honestly just say we'd love you to go test it out. So go use it for your own, ML use cases. If you're trying to build models, if you're trying to go work in industry, I think in general, whether you use us or not is less important in this context. I think what we're arguing is that these are useful ideas to incorporate into the way that you build and manage models as a general rule. So whether there's open source tools that you love, whether you want to use Comet or something else, use them all and see what makes the most sense for your use case and your model and go with that. I'm not going to pretend like I know what you're working on and tell you that ours is the best tool. But in industry, for all of the reasons that we mentioned, weird things are going to happen. Keeping track of everything matters. Building meaningful ML systems is hard, and it makes it a lot easier when you're managing everything in this way. So I'm equivocating and avoiding answering, but I would say use what you want, test them all out, see what works best. But you should use something.
Thank you so much, Nico and Doug, again. This was an awesome talk, and I think everyone really enjoyed it. Let's thank them once more.